The Earth was formed around 4.6 billion years ago through a process known as accretion. It began with a giant cloud of gas and dust known as the solar nebula. This nebula began to collapse under its own gravity, causing it to spin faster and flatten into a disk shape. In the center of this disk, a protostar began to form. This protostar would eventually become our Sun. Around the protostar, small clumps of dust and gas began to collide and stick together. Over time, these clumps grew larger and larger, forming planetesimals. As these planetesimals continued to collide and merge, they formed even larger bodies known as protoplanets. The protoplanets that collided and merged to form the Earth were made up of rock and metal. As they grew larger, they began to generate heat through radioactive decay, which caused them to melt and differentiate into layers based on their density. The early Earth was a hot, molten ball of rock with no atmosphere. However, over time, volcanic eruptions released gases into the atmosphere, creating the first atmosphere of the Earth. As the Earth cooled, its surface solidified, and water vapor in the atmosphere condensed, forming oceans. The movement of the Earth's tectonic plates caused the continents to form, and the Earth's atmosphere evolved to include oxygen and other gases necessary for life. Today, the Earth is a beautiful, complex world with a rich history that scientists are still uncovering. Currently, the only planet that we know of that is habitable like Earth is Earth itself. However, in recent years, astronomers have discovered thousands of exoplanets, planets orbiting stars other than the Sun, and some of them are considered potentially habitable based on certain criteria. To assess the potential habitability of an exoplanet, scientists look at a range of factors, including the planet's size, mass, and distance from its star, as well as the composition of its atmosphere and the presence of water. Here are a few examples of exoplanets that have been identified as potentially habitable. Kepler 438b is an exoplanet that was discovered by NASA's Kepler spacecraft in 2015. It is located around 640 light-years away from Earth in the constellation Lyra and is estimated to be about 640 light-years away from Earth. Kepler 438b is a small planet, only slightly larger than Earth, with a radius of about 1.12 times that of Earth. It orbits a red dwarf star, Kepler 438, which is smaller and cooler than the Sun, at a distance of about 42 million kilometers, 26 million miles. This puts Kepler 438b within the habitable zone of its star, the region where the temperature is just right for liquid water to exist on the surface. However, while Kepler 438b is located within the habitable zone, it is not necessarily a habitable planet. Scientists have estimated that it has a surface temperature of about -35 degrees Celsius, -31 degrees Fahrenheit, which is much colder than Earth's average temperature of 15 degrees Celsius, 59 degrees Fahrenheit. In addition, Kepler 438b may not have a thick enough atmosphere to support life, and it may be subject to high levels of radiation from its star. Despite these challenges, Kepler 438b is still considered an important discovery in the search for habitable exoplanets. It is one of the most Earth-like planets found so far, and its discovery has helped scientists refine their understanding of the types of planets that are most likely to be habitable. TRAPPIST-1e is an exoplanet located within the habitable zone of the TRAPPIST-1 system, which is a group of 7 Earth-sized planets orbiting a small, cool star called TRAPPIST-1. The TRAPPIST-1 system is located about 40 light-years away from Earth in the constellation Aquarius. TRAPPIST-1e is the 4th planet from the star, with an orbital period of about 6.1 Earth days. TRAPPIST-1e is about the same size as Earth, with a radius that is only about 10% larger. It is likely to have a rocky composition, similar to Earth, and it receives about the same amount of energy from its star as Earth receives from the Sun. This puts TRAPPIST-1e in the habitable zone of the TRAPPIST-1 system, the region around the star where temperatures are suitable for liquid water to exist on the surface of a planet. The potential habitability of TRAPPIST-1e has generated a lot of interest among astronomers and the public alike. In 2017, observations with the Hubble Space Telescope found evidence of a thin atmosphere around the planet, which suggests that it could potentially support life. However, it is not yet clear what the atmosphere is made of, and further observations will be needed to confirm the presence of water or other signs of habitability. TRAPPIST-1e is just one of several potentially habitable planets in the TRAPPIST-1 system, which makes it an important target for future studies of exoplanet habitability. The discovery of these planets has also led to new questions about the possibility of life elsewhere in the universe, and astronomers are continuing to search for signs of life beyond our solar system. Proxima Centauri b is an exoplanet that was discovered in 2016 orbiting the closest star to our solar system, Proxima Centauri. The planet is located approximately 4.2 light-years away from Earth, in the habitable zone of its star, which is the region around a star where temperatures are suitable for liquid water to exist on the surface of a planet. Proxima Centauri b has a mass that is about 1.3 times that of Earth, making it a super-Earth. It orbits its star at a distance of about 7.5 million kilometers, 4.7 million miles, which is much closer than Earth's distance from the Sun. As a result, the planet has a very short orbital period of only 11.2 Earth days. Despite being located in the habitable zone, Proxima Centauri b is a challenging planet to study in detail. It is located so close to its star that it is likely to be tidally locked, meaning that one side of the planet is always facing the star while the other side is always in darkness. This could result in extreme temperature differences between the two sides of the planet, making it difficult for life to exist. In addition, Proxima Centauri is a small, cool star known as a red dwarf. Red dwarfs are known to be more active than stars like the Sun, and they can emit intense bursts of radiation and flares that could be harmful to life on planets in their habitable zones. Proxima Centauri b may be particularly vulnerable to these events due to its close proximity to the star. Despite these challenges, Proxima Centauri b remains an important target for astronomers interested in exoplanet habitability. It is one of the closest potentially habitable exoplanets known to us, and it represents an exciting opportunity for further study and exploration in the search for life beyond Earth. It's worth noting that even if a planet meets some of the criteria for habitability, it does not necessarily mean that life exists there. The search for habitable exoplanets is an ongoing and exciting area of research, and as technology advances, astronomers may be able to detect more planets that are similar to Earth in terms of their potential for habitability.